Good afternoon. Today I am going to discuss the topic is RH criterion, which is in the subject of control system. So, the full form of RH criterion is Routh-Hurwitz criterion. Now, what is the criteria says? RH criteria states that it is the algebraic method for determining the stability of a system. Actually, what we will do? We will find out the location of the poles with the help of RH criteria. Okay. Now, suppose we will consider a characteristics equation is a0 s to the power n plus a1 s to the power n minus 1 plus a2 s to the power n minus 2 plus dot 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 up to a1 to 0. Where is a0, a1, a2? These are the constant. So, what is we will doing? The first step, that is step 1. Step 1, to form two rows with help of this constant. Form two rows with help of the non-zero constant. These are non-zero constants. Okay. So how we will form, say, row 1. And this is say row 2. Row 1 is, it is like in the zigzag, like this. If I place the first constant is here, next will be here, then it will be here, then here, like this. This, like this. Okay. So first one is A0. So A0, then is A1, next is A2. So A2 will place here, A2. Next is A3. Next A4 will place here like this. Next is A5 like this. Okay. Now what is the step 2? Step 2, form the third row. Form third row with help of row 1 and 2. Okay. So row 1 is already exist. Row 2, row 3, so row 1 is what? A0, then it is A1, then it is A2, A3, A4, A5. Say I have written this one as B1, B3, B5. Now how to calculate this B1? B1 is nothing but minus 1 by A1, determinant of this and this, that is A0, A1, A2, A3. Next we will form B3. B3 equal to what? B3 equal to minus 1 by A1. This will be fixed, that is A0, A1. A0, A1. Next, instead of this, we will write this A4, A5. Like this. Same as B5. Minus 1 by A1. It will be fixed A0, A1. There is no element. So make it 0, 0. Clear? So this is how we will form the third row. Now with the help of these two rows, that is row 2 and row 3, we will form another row, that is row 5. So step 3. Form fourth row with help of row 2 and 3. So your R1, next R2, R3, that is row R4. So R1 is what? R1 is, this is say A0, A2, A4, A1, A3, A5. Now we will form, this is already formed, that is B1, B3, B5. Now we will form this row 4. Say it is C1, C3, C5. Now C1 is equal to what? Minus 1 by B1 minus 1 by B1, determinant of A1 B1 A3 B3, A1 B1 A3 B3, C3 minus 1 by B1 A1 B1 A5 B5. Like this we will form. Okay. So now, what is the actual statement of Arrhenius criteria? If the sign of this all elements of this first column is positive, then we say the system is stable. And if any sign changes, then the system is unstable. Say my A0 is plus, A1 is plus, then B1 is minus, C1 is again plus, then D1 is say again minus. So what is the number of sign change occurred? Here positive to negative one change, then positive to negative third change, and here another change is occurred minus to plus, that is plus to minus, minus to plus, again plus to minus. So three changes are occurred. So here the number of roots in the item of expression is 3. See, positive to negative, that is one change, then negative to again positive, that is the second change, then positive to again negative, that is the third change. So with this help of this condition, we will calculate the stability of the system. Say, take it an example. Say, find out the stability of the system. The characteristics equation is given as S4 s to the power 4 plus 2s cube plus 6s square plus 4s plus 1 is equal to 0. Okay. So first what we will do, we will form the row. So highest power s is 4, so s to the power 4, then s cube, then s square, then s to the power 1, then s to the power 0. Now what is the coefficient of this s to the power 4? That is 1. So we will write 1 here. Then what is the coefficient of s cube? That is 2. Then what is the coefficient of x square? That is 6. We will not write 6 here, we will write 6 here. Then 4, then 1, like this. It will, no elements is there, so it is 0. Now we will calculate this value. Say I am written, this is say, so this is my A1, this is A0, say, this is my A1, this is A2, this is say A3, this is say A4, and this is say A5. So first I will calculate B1. Okay, so B1 is equal to what? B1 is equal to minus 1 by A1, A0, A1, A2, A3, A0, A1, A2, A3. Now what is A1? A1 is 2, so minus 1 by 2, A0 is 1, A1 is 2, so 1, 2, 6, 4. So determinant means this into this minus this into this. So it comes 4 minus 12, that is minus 8 by minus 2, so it is plus 4. So B1 comes out to be plus 4. Clear? Now B3 is what? So these are rough portion. What actually rough? B3 is equal to minus 1 by A1, A0, A1 is fixed, A0, A1, then A4, A5, A4, A5. My target is to fulfill this first column anyhow. We will not bother about these elements. So A1 is 2, so minus 1 by 2, 1, 2, 1, 0. So it is minus 1 by 2, 0 minus 2, minus 2 by minus 2 is plus 1. So B3 is your plus 1. We will ultimately calculate this B5, so assume it to be 0, right? Because it is 0, so we will get 0. Now we will calculate this C1, and we will calculate C1. This is say C3, this is say C5, and this is a D1. We will bother about this first column. With the help of the sign of this first column, we will find out whether the system is stable or not. Okay. So C1 is equal to what? C1 is equal to minus 1 by B1, A1 B1, A3 B3. So minus 1 by B1 means minus 1 by 4, 2, 4, 4, 1. So it is how much? 2, 4, 4, 1 means minus 1 by 4. It is how much? 2 minus, this is 16. So minus 14 by minus 1, that is 14 by 4, that is 7 by 2. So 3.5. So it comes out to be 3.5. It is 3.5. Okay. Next, what we will do? We will calculate this D1. Now D1 is equal to what? D1 is equal to minus 1 by C1, minus 1 by C1, D1 C1, D3 C3. So C3 also we will have to calculate. C3 is how much? C3 is equal to C3 is equal to what? C3 and D1. C3 is equal to what? C3 equal to minus 1 by B1, A1 B1 and A5 B5. B1 is how much? B1 is 4. A1 is how much? A1 is 2. So 2, 4. A5 is how much? 0. This is 0. So it comes out to be 0. So C3 is also 0. It is also 0. So D1, last one. So D1 is equal to what? Minus 1 by C1, B1 C1, B3 C3, B1 C1, B3 C3. So minus 1 by C1 means minus 1 by 3.5, B1 C1 means 4 and 3.5, and it is B3 is 0, 1 and it will be 0. So it comes out to be how much? It is 0 minus 3.5 by minus 3.5, it is 1. So D1 is 1. So I have got all the elements of this first column 1, 2, 4, 3.5 and 1. So there is no sign changes. So the system is stable. So the system is stable. And if one sign changes is occurred, suppose we have got 1, 2, it is minus 4, then 3.5, then 1, then the system is unstable. And how to calculate the number of the roots in the right of our spin? It is positive. So positive to negative 1 changes, again negative to positive another changes. So 2 changes are occurred. So number of roots in the right of our spin in that case is 2. So it will totally depends upon the sign of the first column. This is how we will calculate the stability from the RH value. That's it.